Hello Piplu, welcome my knowledgeable class.
And the final D today in next part question in supercomputer. Definition of supercomputer.
It's my pleasure to give you answer. Supercomputers are high-performing mainframe systems that solve complex computations. They split tasks into multiple parts and work on them in parallel, as if there were many computers acting as one collective machine.
Explain supercomputer.
A supercomputer refers to a high-performance mainframe computer. It is a powerful, highly accurate machine known for processing massive sets of data and complex calculations at rapid speeds. What makes a supercomputer super is its ability to interlink multiple processors within one system. This allows it to split up a task and distribute it in parts, then execute the parts of the task concurrently, in a method known as parallel processing. You have to use parallel computing to really take advantage of the power of the supercomputer. Caitlin Joanne Ross, a research and development engineer at Kitware who studied extreme-scale systems during her residency at Argonne Leadership Computing Facility, told Built-In. There are certain computations that might take weeks or months to run on your laptop, but if you can parallelize it efficiently to run on a supercomputer, it might only take a day. To put that speed in perspective, a person can solve an equation on pen and paper in 1 second. In that same time span, today's fastest supercomputer can execute a quintillion calculations. That's 18 zeros. Soumya Bhattacharya, system administrator at the Supercomputing Center for Education and Research, explained it like this: imagine 1 quintillion people standing back to face and adding 2 numbers all at the same time, each second, he said. This line would be so long that it could make 1 million round trips from our Earth to the Sun. Originally developed for nuclear weapon design and code cracking, supercomputers are used by scientists and engineers these days to test simulations that help predict climate changes and weather forecasts, explore cosmological evolution, and discover new chemical compounds for pharmaceuticals.
Dancing mood.
Okay. Wow Piplu, enjoy, thanks. Start question Piplu.
How do supercomputers work?
Supercomputers can perform multiple operations at once in parallel thanks to a multitude of built-in processors. This high level of performance is measured by floating point operations per second, flops, a unit that indicates how many arithmetic problems a supercomputer can solve in a given time frame. How it works: an operation is split into smaller parts, where each piece is sent to a CPU to solve. These multi-core processors are located within a node, alongside a memory block. In collaboration, these individual units, as many as tens of thousands, communicate through internode channels called interconnects to enable concurrent computation. Interconnects also interact with input-output systems, which manage disk storage and networking. How's that different from regular old computers? Picture this: on your home computer, once you strike the return key on a search engine query, that information is input into a computer system, stored, then processed to produce an output value. In other words, one task is solved at a time. This process works great for everyday applications, such as sending a text message or mapping a route via GPS. But for more data-intensive projects, like calculating a missile's ballistic orbit or cryptanalysis, researchers rely on more sophisticated systems that can execute many tasks at once. Hence supercomputers.
Supercomputers used for.
Supercomputing's chief contribution to science has been its ability to simulate reality. This capability helps humans make better performance predictions and design better products in fields from manufacturing and oil to pharmaceutical and military. Jack Dongara, a Turing Award recipient and emeritus professor at the University of Tennessee, likened that ability to having a crystal ball. Various use cases and fields of study enlisting the help of high-performance computing. First topic in use: weather forecasting and climate research. When you feed a supercomputer with numerical modeling data, gathered via satellites, buoys, radar and weather balloons, field experts become better informed on how atmospheric conditions affect us, and they become better equipped to advise the public on weather-related topics, like whether you should bring a jacket and what to do in the event of a thunderstorm. टर-जनर, a petascale supercomputer, is being used to explore the effects of solar geoengineering, a method that would theoretically cool the planet by redirecting sun rays, and how releasing aerosols influence rainfall patterns. Second uses in field genomic sequencing. Genomic sequencing, a type of molecular modeling, is a tactic scientists use to get a closer look at a virus DNA sequence. This helps them diagnose diseases, develop tailor-made treatments, and track viral mutations. Originally, this time-intensive process took a team of researchers 13 years to complete. But with the help of supercomputers, complete DNA sequencing is now a matter of hours. Most recently, researchers at the Stanford University scored the Guinness World Records title for fastest genomic sequencing technique using a mega machine method that runs a single patient's genome across all 48 flow cells simultaneously. Third uses in aviation engineering. Supercomputing systems in aviation have been used to detect solar flares, predict turbulence, and approximate aeroelasticity, how aerodynamic loads affect a plane, to build better aircrafts. In fact, the world's fastest supercomputer to date, Frontier, has been recruited by GE Aerospace to test open fan engine architecture designed for the next generation of commercial aircrafts, which could help reduce carbon dioxide emissions by more than 20%.
Fourth use.
Fourth use in space exploration. Supercomputers can take the massive amounts of data collected by a various set of sensor-laden devices, satellites, probes, robots, and telescopes, and use it to simulate outer space conditions Earthside. These machines can create artificial environments that match patches of the universe and, with advanced generative algorithms, even reproduce it. Over at NASA, a petascale supercomputer named Aitken is the latest addition to the Ames Research Center that is used to create high-resolution simulations in preparation for upcoming Artemis missions, which aim to establish long-term human presence on the Moon. A better understanding of how aerodynamic loads will affect the launch vehicle, mobile launcher, tower structure, and flame trench reduces risk and creates safer conditions.
Fifth uses in supercomputer.
Nuclear fusion research. Two of the world's highest performing supercomputers, Frontier and Summit, will be creating simulations to predict energy loss and optimize performance in plasma. The project's objective, led by scientists at General Atomics, the Oak Ridge National Laboratory, and the University of California, San Diego, is to help develop next-generation technology for fusion energy reactors. Emulating energy generation processes of the sun, nuclear fusion is a candidate in the search for abundant, long-term energy resources free of carbon emissions and radioactive waste.
How fast is a supercomputer?
Today's highest-performing supercomputers are able to compute simulations in the time it would take a personal computer 500 years, according to the Partnership for Advanced Computing in Europe. Fastest supercomputers in the world. Frontier, operating out of Oak Ridge National Lab in Tennessee, Frontier is the world's first recorded supercomputer to break the exascale, sustaining computational power of 1.1 exaflops. In other words, it can solve a quintillion calculations per second. Built out of 74 HP Cray-X supercomputing cabinets, which weigh nearly 8,000 pounds each, it's more powerful than the top 7 supercomputers combined. According to the laboratory, it would take the entire planet's population more than 4 years to solve what Frontier can solve in 1 second. Fugaku debuted at 416 petaflops, a performance that won it the world title for 2 consecutive years, and, following a software upgrade in 2020, has since peaked at 442 petaflops. It's built with a Fujitsu A64FX microprocessor that has 158,976 nodes. The petascale computer is named after an alternative name for Mount Fuji, and is located at the Riken Center for Computational Science in Kobe, Japan. LUMI, a consortium of 10 European countries, banded together to bring about LUMI, Europe's fastest supercomputer. This 1,600 square foot, 165-ton machine has a sustained computing power of 375 petaflops, with peak performance at 550 petaflops, a capacity comparable to 1.5 million laptops. It's also one of the most energy-efficient models to date. Located at CSC's data center in Kajaani, Finland, Lumi is kept cool by natural climate conditions. It also runs entirely on carbon-free, hydroelectric energy while producing 20% of the surrounding district's heating from its waste heat. Leonardo is a petascale supercomputer hosted by the Sinica data center based in Bologna, Italy. The 2,000 square foot system is split into 3 modules, the booster, data center and front-end and service modules, which run on an Atos Bulls-Aquana XH2000 computer with more than 13,800 NVIDIA Ampere-PS. At peak performance, processing speeds hit 250 petaflops,